Hello. Today's lesson is graphing equations into variables. To graph an equation, we're going to recall how to plot points on a Cartesian plane. Well, we learned that in the past, and we can make a collection of points which can make a line, create a line. So let's start off with our definition. The graph of an equation is in two variables. X and y is a set of points whose coordinates x comma y in the xy plane that satisfy the equation. One way to graph a line is by the point plotting method. And if you're ever asked to graph something you're not sure how it looks like or how to start, point plotting is a good way to start. So to do so, we first have to choose values, substitute them into our equation. Write as a coordinate point. Remember, every point is x comma y. And then plot the points and connect the dots. Alright, so I have an example. Here being asked to graph the equation y equals 2x minus 3 using the point plotting method. Alright, to do so, you have to pick some points. And we're going to plug in points into our x. Because notice that our answer, it's always equal to y. So if we plug in a value for x, a number, our answer is going to be our y point. Okay, now when I say plug in, we say substitute. Plug in isn't really what you like to use in math. Okay, so I chose these points for you, but you can pick any points you like. There is no right or wrong answer. If you choose a point, because it's an equation, it's going to give you the correct outcome. Okay, so let's go ahead and figure this out. So we have our equation y equals 2x minus 3. And for x, we're going to plug in a negative 2. That's what we have on our first row. Alright, so I have y equals 2 times negative 2 minus 3. Alright, work this out. 2 times negative 2 is negative 4. So I have negative 4 minus 3, which is negative 7. And that's our y. Now let's go ahead and plug in negative 1. So y is equal to 2 times, instead of x, I'm going to write negative 1. And I have a minus 3. I work that out. 2 times negative 1 is negative 2. Minus 3, we get negative 5. Next, I have y times, y is equal to 2 times 0 minus 3. That gives us 0 minus 3, which is just negative 3. Y is equal to 2 times 1 minus 3, which is 2 minus 3, negative 1. And then 2 times 2 minus 3, which gives us 4 minus 3, and we get 1. Okay, now remember, these collections of x comma y give us points. So we have our x and we have our y. Let's write them as a coordinate pair. So I have negative 2, negative 7, negative 1, negative 5, 0, negative 3, 1, negative 1, and 2, 1. Let's go ahead and plot those points. Alright, if we plot them, we have negative 2, right here, negative 2, negative 7, negative 2, all the way down to negative 7, which is there. We have this point here. Now we have negative 1, down 5, 1, 2, 3, 4, 5, 0, down 3, 1, 2, 3, and 1, negative 1, and lastly 2, comma 1, 2, up 1. If I connect them, you might need a straight edge, a ruler. If we connect them, they make a line. And this is our line. Y is equal to 2x minus 3. And we see that a collection of these points gave us this line. Okay, go ahead and try these two problems. For the sake of us having the same points, let me guide you and tell you what points I would like for you to choose. But keep in mind, you can choose whatever you like. So for the first one, why don't we choose numbers like, for x, let's pick 0, 1, and 2. Do the work to find your matching y coordinate. And for the second one, let's pick points like the same, 0, 1, and 2. Now the reason I chose these points is because I know they won't go out of our grid, and that way we can use the grid we have. So go ahead and try these problems. They're for you to try. Pause the video and see what you get. When you're done, you can unpause the video so you can see the answer. Alright, let's go ahead and work it out. So our rule for the first one is y is equal to 3x minus 2. Okay, we're going to work this out. Let's see what we get. When 3, if we let x be 0, 3 times 0 is 0, 0 minus 2, you get negative 2 for y. 3 times 1 minus 2, well, 3 times 1 is 3, minus 2, we get 1. And I'm going to squeeze this on the side right here. 3 times 2 minus 2, 3 times 2 is 6, minus 2, we get 4. Alright, so our coordinate points, we want x comma y, are 0, negative 2, 1, 1, and 2, 4. Let's go ahead and plot these points. So I have 0, negative 2, 1, 1, and 2 up 4. Alright, we connect these points, and they're our line. Now the next one, let's go ahead and see what we get. So our rule for this one, our equation is y is equal to negative 4x plus 8. Let's go ahead and replace the x with a number. We're going to plug in a 0, a 1, and a 2. Alright, so that we have negative 4 times 0 plus 8. We get 8. Negative 4 times 1 plus 8. Negative 4 plus 8, we get 4. And negative 4 times 2 plus 8, we get negative 8 plus 8, 0. So this gives us the coordinate point 0, comma 8, 1, comma 4, and 2, comma 0. Let's go ahead and plot them. So I have 0 up 8, right there, 1 up 4, and 2, comma 0. So these points create our line. And there we go. We have graphed by plotting points. Let's move forward. A new definition is a linear equation in two variables is an equation that can be written with the form ax plus by equals c, where a, b, and c are real numbers. This is also called standard form of a line. X and y are to the first degree, meaning there is no exponent on the variables. Just a little hint. Alright, so it's saying that a, b, and c can be numbers. So our only variables are x and y. So a linear equation in two variables is an equation that has two variables, x and y. Now when x and y are to the first degree, it creates a line, hence linear equation. If you decide to go into college algebra, you'll graph a lot more of equations. Not all of them are lines. Not all of them are linear. Let's go ahead and take a look at our next example. Determine whether the equation is a linear equation in two variables. So we want two variables. The first one, A, we see we have an x and a y, and they're both to the first degree. That one, yes, that one's a linear equation in two variables. B, we have x squared plus 5y equals 10. That square makes it so it's not a line. Okay, C, I have 1/2 x plus 2y, 2 over 3y equals 4. Remember, we can have any number for our coefficient, even fractions. It just says that A, B, and C are real numbers. So that one checks off. That one is. Now D, negative 2y minus 5. This gives us a line. Now for this one, it so happens that our x has a coefficient of 0, but this one's also a linear equation. Okay, let's do another example. Let's graph the linear equation 2x plus y equals 4. Now, this equation is different. We're used to having y equals our equation. Right? Here, our y is not by itself. So that's why we had some problems in the past where we're being asked to isolate. This is one of the reasons why we do this. Sometimes in some equations, we have to rework them to get what we want. So first, you want to isolate the y. That's if we want to do it by our process of point plotting. Okay, so we have 2x plus y is equal to 4, and we want to get y by itself. So let's go ahead and move that to x. Minus 2x. 2x minus 2x is 0, so it's gone. But what we do to one side of the equation, we have to do it to the other. So minus 2x. So I'm left with y is equal. Let's write the x first. We have a negative 2x minus 2x. My 4 is positive plus 4. Okay, this is something I can work with. We're being asked to graph, so let's go ahead and do a chart. Let's choose some points. Let's pick 0, 1, and 2, like we have been doing. Now our equation that we're going to work with is y is equal to negative 2x plus 4. Let's let x be 0. That's our x, so we're going to replace x with 0. I have negative 2 times 0 plus 4. That gives us 0 plus 4. We get 4. Negative 2 times 1 plus 4. We get negative 2 plus 4, 2. Negative 2 times 2 plus 4. Negative 4 plus 4, 0. So what are our points? The points are going to graph are 0, 4, 1, 2, and 2, 0. Let's go ahead and plot them. So I have 0 up 4, 1 up 2, and 2, 0. If we connect them, we get our line. Now, I recall some professors or teachers are very picky as to how many points to make up a line. And in reality, to make a line, if you know it's going to be a line, 2 would suffice. But in the future, if you go on to take another math course, listen to whatever the instruction your professor wants. Alright, now we have some you try it problems. So graph the linear equation using the point plotting method. Alright, I'll let you try it. Right now is a good time to pause the video so you can give yourself plenty of time to give it a try. Once you're done, unpause it and we'll work this out together. Okay, let's see what the problem looks like. So just like before, my y is not by itself. Right, you take a look at your equation and you're like, ooh, that y. I need to get that by itself. Just like before, this one is only one more step to do. Okay, I need to move that 3x so I can get y by itself. So if I have negative 3x, if I add 3x, I get 0. So add 3x to both sides. And we're left with y is equal to, let's write our x first. 3x, it's positive, minus 6. 6 is negative. So that's the equation we would like to work with. So let's go ahead and choose some points to plot. Let's do 0. Let's do one more. Let's do 2 points. Our equation is y is equal to 3x minus 6. If I substitute in a 0, I'm left with 3x, or 3 times 0 minus 6. 0 minus 6, we get negative 6. 3 instead of x, I'll write 1 minus 6. 3 minus 6, negative 3. So points I'm left to graph are 0, 6 and 1, negative 3. 0, up 6, and 1, down 3. Oh, that first one's wrong, negative 6. First one is 0, negative 6. Alright, and if we connect them, we have our points. If you're ever unsure, you can always plot more points. And those things at the end are supposed to be arrows. Sorry for my very poorly drawn arrows. Alright, next one, we have 2y plus 3y equals 12. Same problem, I need to get y by itself. So I have 2x plus 3y is equal to 12. Now let me highlight what we want to get by itself. We want to get y by itself. Okay, so I'm going to have to move that 2x. 2x minus 2x, that gives me 0. And remember, what we do to one side of the equation, we have to do to the other. That's gone. Let's rewrite our equation. We have 3y is equal to, let's write x first. It's a negative, so we write minus 2x. Our 12 is positive, plus 12. Okay, we want to get y by itself. We see that's being multiplied by 3. Well, we see that if we so happen to divide by 3, 3 divided by 3 gives me 1. So that will make it so that my y is by myself. Now let's remember what we do to one side of the equation, we have to do to the other. Let's rewrite this. We have 3y is equal to negative 2x plus 12 over 3. Now this 3 is dividing both terms in the numerator. It's dividing the negative 2x, and it's dividing the 12. Yes, I drew a heart. I drew a heart to show you that it's dividing each term in the numerator separately. So let's write it as divided by 3 separately for each one. Ooh, that 3 was gone, right? We divided it out here. So that we have y is equal to 2 over 3x plus 12 over 3. 12 divided by 3 is 6. Okay, this gives us an equation we can work with. Let's go ahead and do our grid, our chart. Let's plug in points like 0. And let's go ahead. Well, I want to be clever. I see I have a denominator of 3. So let's multiply by 3 so that it can divide out. Okay, let's work this out. So I have negative 2 over 3 times 0 plus 6. 0 plus 6, we get 6. Negative 2 over 3 times 3 plus 6. We can write it as 3 over 1, and we see that my 3's divide out. So we have negative 2 plus 6. We get 4. Now, if you don't like that, you can choose to not do so, and you'll work with fractions, and that's okay. Fractions are our friend. Alright, so I have 0 up 6 and 3 up 4. Sorry for the train noise in the background. And that's our line. Alright, so that's it for our lecture on graphing equations of two variables. There's different ways of graphing a line, but our good starting point is by doing a chart and choosing points to create our line. If you have any questions, you can post them on our discussion board, email me, but make sure you get your questions answered. Thanks.